Good morning, everyone. This is Andrew Kimmons with Kimmons Toolworks, and I have the next video here in the series I'm doing about the process of making the tools. And that was just one of the things that a lot of people requested and wanted to see. They wanted to see behind the scenes of how it all gets done and all that. And it's one of those things that I have to actually consciously think about doing, because normally I completely dissociate the social media from the actual work. Normally, I do this for the work, not for the social media aspect of it or for the fun of making videos necessarily. I am about the furthest thing on the planet from a content creator, and the fact that I can even stand here and make a video about this is kind of odd to me. But it's just, I am very much not that kind of person. So I make tools for the love of making tools, not for the love of standing in front of the camera and talking to it. So big dissociation between the two. Anyway, the next part of the process I wanted to share with everyone is one of the more, I guess, intricate but very simple parts of the process. It has its intricacies to it, but I wouldn't necessarily call it hard. This is one of the components that a couple of years ago, I was looking into having produced by a local CNC machine shop, because it's a very small, very intricate part, and it has to be made really accurately. If the sockets aren't made accurately, then from chisel to chisel, they'll be different. The gap will be different. And there's always a gap between the socket and the handle itself. You see a little gap there, and that's just room to tighten up, just room to crush if it needs to. It literally won't move, but it's better to have it be able to go somewhere, essentially, so that's why there's a gap. I had gone to a local machine shop and showed him the part and asked basically what it would cost to make this part. I took a drawing of the exact dimensions, and this is without the slot, just the actual part without the slot up here. I told him, I was like, I'll mill the slot, don't worry about that. And he said probably like $11 a piece, and I was like, that's really not that bad. And he told me, he's like, I'll get you an actual quote by Friday. So all right, Friday came around, didn't get a quote, so I contacted him Monday. I was like, so what is this gonna cost to do these things? And I wanted a quote for 100 of them, and he sent me the quote, and it was almost $3,000 for 100 of them. And I was like, there's a big difference between $11 a piece and $28 a piece. Like, that didn't even include the programming fee. It was like $80-something to program the machine to do it, and then $28 a piece to turn these things. And like, even on camera, going slow, talking, things like that, it's not going to take me a half hour to make one of these things. So I'm not going to pay somebody to do that. I'd rather that's money I can make rather than spend. So it was just kind of stupid. It's like, man, if I had a CNC machine, I guarantee you I could do that part a hell of a lot cheaper than $28 a piece. But we all know this, that when people have jobs come along that they don't want to do, they overquote the hell out of them. They will overprice the hell out of it. And he didn't want to do that job because of how small and intricate the part was, how small the boring bar would need to be. All of these things that he said were little complexities that make it a difficult part. I'm sorry. Maybe this is just me. This isn't a difficult part. And if you own a machine shop, if you own a CNC machine shop, and you can't make this part for less than $28, that's piss poor capabilities. I'm sorry, but something is severely lacking if that's the case, because not every part that you need to machine is always going to be super simple and big and user friendly and that doesn't require specialty tooling and all kinds of stuff. It's like, you got one job. Like, I have many jobs, just machining parts is one of my jobs. And $28 a piece was kind of nuts for that. I didn't even go get a second quote. I was like, I don't want to waste my time on it because the next guy is going to do the same thing. Because people don't want to take on something that's remotely challenging at all. They want to just absorb, because I live in like a little factory town. They can just absorb all of this contract work and like easy crap and overcharge the crap out of them. Just like how when you have a company like a supply company like a Granger or whatever like that, if they're selling you a hammer, it might be $20-30. If they're selling it to a major corporation or government, it's going to be a $150 hammer. Why? Because they know that whoever's signing off on that doesn't care. They know it's not their money. They're like, whatever, $150 hammer, cool, whatever. So there's a lot of corruption and things like that. So these dudes that own the little machine shops locally, I guarantee you, they just absorb a lot of work that's like that, where somebody's just pencil whipping it, where it's like, oh, that part cost $3,000 to machine, okay, fine. And it's like a $100 part that I probably could have made for like $200. So anyway, moving on. I could stand here and ramble all day. The part that we're going to make is the socket, and these have very specific dimensions and very specific angles. And we start with a piece of stainless steel bar stock like that, and it does become like this before it is severed. And this angle right here, I actually don't do this by angle per se. It's close to 10 degrees, but it's not exactly 10 degrees, and I didn't want it exactly 10 degrees because there's little things that I design into my tools to where I can measure them and tell if I made them, because if somebody ever comes along that's trying to clone them, or Chinese clones, like, they're not going to get so accurate that they know the angle by thousandths of an inch travel across that. So like when I set the cross slide on my lathe, I actually, it's like, how many thousandths does the dial indicator move per inch of travel? So, and it ends up close to 10 degrees, but only I can differentiate probably, unless you actually do the same process, and then you'll know the numbers. But anyway, we have to get them to this state first, which is a roughly 10 degree taper on the inside, a roughly 10 degree taper on the outside, flat bottom, gotta have a flat bottom, and then here we have a 1/4 inch hole that's threaded. And it's threaded so that it can fit on a fixture for milling. And this is the part that's close to finished. From here, it'll be parted off, which I do that with a grinder. I've found that a grinder and a cutoff wheel is easier to part that off rather than... I have a 4-way tool post on my lathe, but when you're running a boring bar, there's no room for the 4th tool. So I would have to take a tool out to put a parting tool in to just do that part, and it's stupid. I'd rather just zip it off with a grinder. So I make these a little extra long, that way I can zip them off with a grinder. They go in a holding fixture where they're held, and then I machine the face flat to where it's the correct length, and then in that same holding fixture it goes to the mill and then gets slotted. So not really all that complicated, but we're gonna go ahead and make one on the camera here, and I think it will be a pretty interesting, possibly enlightening thing. And I am a caffeine addict, and it's kind of early, so all right, first things first, what we're gonna do is I have my camera set here to where hopefully this is gonna be a pretty good view. I think this is about the best view that I'm gonna be able to get of it. I'm gonna take this down a little bit more, that way you can see what I'm gonna do here. The first thing that I do, my dial indicator is gonna go on this, the stand that it's on, and then I always make sure the jaws don't have any chips or debris in them before I chuck something up. This is an independent chuck, so each jaw has to be individually adjusted to get it centered. And it sounds like a lot more of a pain in the butt than it really is. It's not that difficult. Normally, the two that I adjust, unless I have to adjust the other ones, when I'm doing like production stuff over and over, is I have each jaw numbered, and I'll usually do most of it, if not all of it, on the number 1 and number 2. But that doesn't mean I don't have to do other ones sometimes. The dial indicator will go on there. It's magnetic. As soon as you turn that switch, it's magnetized to this. And then you can rotate this and see how far it is out. And what I start by doing is, when the indicator climbs to its peak, that means that that's at the highest point where the stock is higher. So you can push those jaws down. And then if I push those jaws down and it still is too high, that's when I will loosen the other ones. So here, 1 and 2 are loose, which is typical. Right now, 1 needs to be adjusted about 1/1000th. And that's it. That's literally it. It's more complicated than that. Like, let's say I switch from machining sockets to end caps, and I put 1 1/4" bar stock in it. It's more complicated to get it centered with switching to a new stock size than it is running the same size over and over. This is 7/8, by the way. And so that's literally it in terms of just putting another of the same stock in. So the tools that I have set up in here currently, and this is kind of funny, but it works really well. I currently have and you can see it here, standard carbide turning tool. This is a DCMT 21.5 insert, I believe, off the top of my head. So it's a good general use turning insert. I like these a lot. I use different than this when I'm turning tool steel, but these work really well in stainless. And make sure there's no chips when I rotate this tool case. I don't like to smash chips up underneath it, but this, you loosen this and it can rotate. It has a stop so that it's 90 degrees to this, but you can just loosen it up and come over the top of the stop. And yes, I have a 3/8 end mill in there with a stop on it. And this essentially functions as a flat bottom drill, and it hits this piece of material and stops as soon as I've achieved the depth that I want. And you're gonna have to kind of bear with me. This one's getting dull, so whatever. It's not gonna be super easy to get that through all the way, but and they do get dull. Like anything, they get dull. And I sharpen my own end mills, so I normally do them like 10 at a time, go through and sharpen them. And yeah, so first thing we're going to do is cut a decent face on this with a standard carbide turning tool. I'm going to have to turn the ventilation system on, that way it doesn't get smoky in here. Good. Now we're going to start boring into it to just get a 3/8 flat bottom hole. And I could drill it with a drill bit, but it's not as accurate as doing it with a flat bottom hole and a stop. And this is usually very quick and very, very easy when the cutting tool is actually sharp. This one, as I mentioned, is not super sharp anymore, but it is still working, so. Doing this particular type of boring, you can really tell when you're not using enough oil. And this is just dark cutting oil. It takes a fair amount of it for sure. Kind of like a hillbilly way of doing it, but it works and it's accurate, and that's all that matters. It's not stupid if it works and it's accurate. It just doesn't matter how weird the cutting tool is. It matters how well the part turns out. Go. We bottomed out. Now what I do, using the same thing, because it's still too small to get my boring bar in there, using the same end mill, I'm gonna cut this hole to 500 thousandths and open it up. And I don't use the auto feed for this. I just do it by hand. You can tell it works pretty dang well. It's not, definitely not bad. And it doesn't matter at this stage, it just doesn't matter what the finish quality is on the inside. What matters is that the hole is 500 thousandths, because I need the width of the bottom of the hole to be 500 thousandths. The only thing that matters at this point is how deep it is and how wide the bottom of the hole is. That is all that matters. Now we're going to take a measurement. And I will use dial calipers to measure it and see how much further it needs to go. Looks like it needs to go 32 thousandths. So half of 32 is 16. And you have to think about, when you move this, it's cutting off of one side, but however many thousandths you take this is essentially double that on the cut. So I need 32 thousandths more. This needs to be open 32 thousandths more. So over here, I'm gonna go and move it to 16 thousandths. So 10, 11, 12, 13, 14, 15, 16. And since the cutting tool's kind of dull at this point, it's probably gonna cut it like 30 thousandths, and I'll probably have to take another 2 thousandths off. But I don't want to overcut it. It's not the end of the world if I overcut it by 2 thousandths of an inch, but it's also not ideal. I mean, the part is either right or wrong. So Now we will check it out and see how well it's doing. And you always want the surface to be free of chips and your calipers to be free of chips. Otherwise, your measurement isn't going to be very good. Oh, that is just dead on. I mean, that is dead on 500 thousandths. I know you can't see it, but I'll try and pull it off of here. And hold this. Dead on. So it doesn't really matter how goofy of a tool you use. What matters is accuracy. And on the last cut, finish quality matters. Like, I would absolutely never take a finish cut with that. That's not designed to make a finish cut on anything but a milling machine. All right, so now I'm gonna go open the air valve for my air compressor because the lines are empty. And the next thing we're going to do is we are going to flip around to the boring bar. And this is a really small boring bar. And it works great for this. What I like to do, since the insert is at an angle, is set the boring bar to where the insert on the face of it is like going in there flat. That way the hole stays relatively flat. That. And then what we do is we run it with the cross slide, because the cross slide's set at that 10-degree angle. So we're going to lock in the carriage and run the cross slide and cut that all the way to the depth. And then you can tell when this hits bottom, it's not going to cut much. It might cut a couple thousandths of an inch, but you can definitely feel when a boring bar bottoms out. It's one of those things that it just takes experience. I mean, there's no replacement for experience. I can sit here and tell you all day long, or you can read it in a book for 25 years, and then actually do it and screw up. So it's just one of those things that takes feel, especially when you're like me and you run the cross slide with this so that it's kind of like auto feed. Yeah, maybe, I'm sure that a lot of manual machinists do the same thing. I have this little, it's a snap-on screw gun. And I just put a swivel on it. It doesn't even need the swivel. I don't know why I have the swivel on there. But yeah, and I just run the cross slide with this, and it works great. And here we go. I mean, you can really take some material off with this thing. And both ways, you can cut going in and coming out. And this part, I can tell just about how much to cut by how deep the boring bar is, because once the boring bar starts engaging near the bottom of the hole, that means this is just about done being tapered. Because, I mean, I designed it to where those two areas meet up, to where the end of the socket and the angle pretty much meet up. So, like, I mean, these things are really kind of hard to describe, but right when that thing gets about to the end, I'm pretty close to done cutting. And I'll show you how I actually get it exact. And there's a lot of ways that you can do it, and I found the most accurate way is the simplest and kind of goofiest thing ever. So once we get to that part, I will do it. We're pretty close. All right, we'll check it. have a socket sitting here that is identical in angle and everything like that. And ultimately what matters is how the depth that this socket sits on the handle. And so I have a socket that has a line that I've scratched into it. And when this part, when it's just the right diameter to where the line goes inside of this lip, that's perfect, because I still have to face this. I'm gonna still have to cut this outer ring a little bit. So once that line disappears, then I can trim it to exactly to where the socket that I'm cutting sits dead center on that line. And then if there's any variation, it's a few thousandths and you'll never even notice it. So it ends up extremely accurately this way. I tried to do this based on measuring it with calipers. And the thing is that if you're measuring it with calipers, if you're accidentally in a few thousandths of an inch too much, or you're out a few thousandths of an inch too much, it throws the measurement off. The only real way to do this manually is to pop this sucker in there and look at it. And this needs to go a few more thousandths of an inch to get the line inside there. And if you cut it a little bit too big, it's not the biggest deal. You can make up for it by trimming an extra couple thousandths here. Because when the handle goes into the socket, the handle doesn't bottom out in there. There's a gap. That way that it can allow movement for compression. So there's little ways, like there are dimensions to a part that absolutely have to be dead on accurate. And then there's dimensions to a part where if they're a couple thousandths off, it's okay because you can make up for it in other places. Because it doesn't really matter at the end of the day if the gap inside the head of the chisel between the end of the socket and the end of the handle, it doesn't matter if that gap is 100 thousandths or 98 thousandths. You literally can't even see it, and it's 2 thousandths of empty space inside of there. So a dimension like that is not critical. Now, it does matter if it's, I would consider it to matter if it was more than 10 thousandths off. Like if it approaches 10 thousandths off, honestly, I don't even do that. Probably 5 thousandths off. That's just getting too far for me. And you can make up for that by reboring the hole, resurfacing it, and you don't have to like scrap the part. You can just cut some off and then rebore it a little bit deeper. And that's what I'll do if it's more than like 5 thousandths off. If it's pushing like 10 thousandths off in that particular dimension with that gap, I'll just do it a little bit deeper, and then hopefully that makes sense. So we're gonna bore a few more thousandths off of here. Nice slow cut. It's getting to the point where finish matters, so we're not just ripping and tearing. And bottom. And we'll clean it out and check it again. That is just to where the line is sitting centered. So that's where we want it at the end point. So which means we probably need to remove literally about 1 more thousandths of an inch. 1 more thousandth. This, I will clean the boring bar, clean the inside. That way I can see the size of the chip coming off. And if you can see the size of the chip coming off, you kind of know how much material you're removing. I mean, common sense things, that kind of obvious. What I'm gonna do, with a boring bar, if you have to literally remove it an extra thousandth of an inch, I'm not even going to adjust this axis. I'm going to leave it right where it is, because no matter what, a cut takes pressure, and boring bars have flex to them. Even if it's just a little nub of it sticking out, there's still some flex and some give to the tool. So I'll be able to go in there and probably cut a thousandth off without even adjusting it, if I move slowly enough. That's not always the case. It depends on how sharp the tool is too. On a fresh insert, that usually doesn't work because it takes less pressure to cut with a fresh insert. A lot of things matter. How the height of the tool matters. Like with this boring bar, if I were to raise this another 10 thousandths of an inch, the cut quality would be terrible and it would chatter really bad. So like the height that the tool sits matters too. There's a lot of little tiny things that matter when it comes to particularly the quality of the finish on a cut. Nice and slow. We may not get a lot of material out, but I guarantee you we'll get some material out. Yeah, we would be lucky if that removed a 10,000. So we're gonna have to adjust it. This is a pretty fresh insert. I'll go just a hair, just a little over 1,000. Now we're cutting something. Once again, it's better to go a little too much than not enough in this instance for the finish cut, which is kind of backwards from reality in most cases, but being that I'm gonna have to trim the end anyway, a little bit extra is just fine. And the reason why, because we surfaced this initially, but the reason why we've got to come through and cut this again is two reasons. One, to get that gap right when it goes on the handle, and two, because the stops will kind of gull this a little bit and it puts a bad finish on it. So I will cut it again, even though it's not super bad. Obviously, when doing this, you want to make sure it is free of debris because that will really throw it off. Let's see where we're at. That's perfect. The line just barely disappears inside of the socket. So that is perfect. And what we're going to do is, from this point, I'm going to end up surfacing this after I drill and tap it, because I use a stop on another one of the drill bits, and if I were to cut this surface now and then drill and tap it, what's going to happen is I'll end up with another gulled surface and have to cut it again, and then it would be out of spec. So when people look at the price of the tools I make, like, there's a lot of little things that go into it, believe me. I wish I could charge less, but there's a lot of intricate crap going on here, and the finish quality of that is perfect. I could not possibly be happier with the finish quality of that. The next thing we're going to do is we're going to introduce the tailstock. This is obviously just like on a wood lathe. This is for drilling or for holding the end of stock or for any number of things. I do a lot of things with a tailstock. The next thing that I do, I have an array of two different chucks over here. This one's a keyless chuck, and it works just fine for some things. I don't drill with a keyless chuck usually, but I use keyless chucks where a little bit of slippage is okay, because everybody knows keyless chucks, no matter what the quality, they will slip. Once again, no chips inside the tailstock taper. We'll go into that. Now what I have here is another end mill. This is a 1/2 inch 2-flute end mill. I normally use a 4, but I'm out of 4-flute end mills at the moment. So I'm using a high-speed steel 2-flute, and I just resharpen the faces on these when they're dull mostly. So what we're gonna do is this, since if you remember, I was saying the hole needs to be exactly a 1/2 of an inch and have a flat bottom. You know, ta-da, 1/2 of an inch flat bottom. Any inaccuracy left as far as the bottom of that hole will be eliminated here. And then I'll take a final depth. I'll use a dial indicator to take a depth, to get the depth exactly where I want it. And those two measurements will match up when I machine the face off. That will line up, will match up with our gap here. And what we want is for the number to come together with this. So we want it 850,000 or 650 thousandths deep, plus or minus about 5 thousandths, and lining up perfectly with the center of this line. If those two things come together, it's a good part. So what we're gonna do, and this can influence the overall depth, so we just want to take it to a point where it is engaging evenly on the bottom, which once again is another feel thing. And you don't want to do something like this with the lathe just ripping away at high speed, because if you have to look at it this way with machining, a continuous speed with a particular cutting tool can create a harmonic. But if you're varying speed, varying pressure, or your flutes on a lot of end mills these days are variable, they're not even, so that a harmonic doesn't get set up. That's where chatter comes from. So on this particular cut, this one is really, really prone to causing a harmonic. And when it does that, it vibrates through the machine, and this machine's pretty heavy. So like, if my daughter is standing on the other side of the shop and I get a harmonic on this particular cut, she says she can feel it in the ground, in the concrete. And the slab on this building is at least 10 to 12 inches thick. So like, it's a hell of a harmonic. So what I like to do is I'll just bump it and kind of do a variable speed thing and run it slow and just feel the cut. Now we're engaged. Now we'll look in there and see what it looks like. A little bit more. That's just taking off a little bit of the shoulder inside of the cut. And that leaves a perfectly flat 1/2 inch hole at the bottom that literally just about has a mirror finish. And yes, to me, finish quality matters even where you can't see it. It still matters because I'll know it's there and I just want it to be the best I can make it. So what I'll do here is I swap this one out with a tap. Reason being, you'll see why, because I actually kind of need the tap to slip in this to some extent. So that comes out of the keyless chuck. My tap goes in it. And then we'll be back to this in a minute. Now I go to my drilling chuck, which is a keyed chuck. This is just a 5/8 keyed chuck that I use for drilling. And I'll go in with a pilot drill bit, which this one in particular is 5/32. And this is one of the few drilling operations where I use a new drill bit rather than resharpened ones, because piloting holes on a lathe, especially if you have to go in deep, any difference side to side on the two cutting heads of the drill bits, it matters. It will try to wander, it'll go off center. So I only use a new drill bit. I don't use a new one every hole. Like, if it gets dull from doing this particular thing, I'll sharpen it and then I'll use it for other stuff, and then I'll replace it with a new drill bit. So now we're gonna go in and we are going to do our pilot hole. And I like to just slide it up until it bottoms out and then back it off a couple thousandths of an inch. Tighten this down. Now, it doesn't even matter how deep we bore this, because it's not going to affect the next part either way. It just doesn't really matter. The depth of this cut does not matter. I could bore the hole through the entire piece of material and it wouldn't matter. So normally I go pretty deep. Better to go too deep than not deep enough with this particular one. I normally don't shut the machine off this many times, but it's probably hard to hear. Now I'll swap this out with the final drill bit. So once again, I have a little stop I made on it that's got two different set screws to hold it tightly exactly at the depth that I want to go. And honestly, the depth of this one doesn't matter so much either, but I just don't really like to waste a bunch of time, and it only needs to go a very slight amount. And I will use a resharpened drill bit for this because there's already a pilot hole in it. This drill bit has been sharpened hundreds of times probably. Pilot hole looks good in there. A little bit of oil. Now I'll slide it up until I can just hear the drill bit touch it. Then back it off a little bit. And then bore it up until the end, the stop contacts it. There we go. And put a little bit of oil. I put a little bit of oil on the stop just to help keep it from galling. There, right when it touches and you see the oil squeeze out, you're done. That's it. Get rid of this chuck, and then we're going to come back with the keyless chuck that we have our tap in. Back to this chuck. A little bit of oil on there, a little bit of oil inside of here. And now I'll come up to it and I'll stop the machine and then just jam that in there. I don't even tighten the tailstock. It doesn't matter. But the machine has to at least come down slow enough to where it's not going to just spin the crap out of my tap in this. It still spins a little bit, whatever. And jam it. And that's it. And then back it out. We've tapped it. It's very easy to tap with machine tools. Now I always like to switch back to the tool that I'll need on the next one, which is our 1/2 inch 2 flute today. Now we're going to take this face cut. We'll make sure that the inside of this is clean, and we're going to get one of my plethora of dial indicators I use. This one, I literally have tools set up for a specific purpose, and I won't mess with them. Like, this tool is set up to only do this one operation. That way I don't have to mess with it. This sucker is permanently fixed on there, and this dial indicator serves literally one freaking purpose, and that is this. And once again, doing these things efficiently is not cheap, because these are not cheap tools, not in the least bit. Okay, it looks like, because that's on the burr, oops, looks like we can cut about 5 thousandths off of there, and that should bring us right about where we need to be. Now I'm going to switch over to the cutting tool that we machined the face with initially. Make sure there's no chips in there. I know I'm OCD, I get it, whatever, don't care. I hear it from everybody all the time, and I don't care. It's not actual OCD. I'm not a mentally ill, crazy person that like gets stuck turning off the coffee pot 75 times because they can't do it right. That's OCD. There's absolutely nothing OCD about me. I'm just kind of uptight about things being right and organized and clean, and it's not everybody's cup of tea. Once again, I don't care. Okay. Now we're going to take our cut, and I like to cut outward, if that makes any sense, because this tool is sitting at an angle, so I can kind of cut outward, and then it keeps it from putting a burr on the inside, because you'd be rolling the burr to the outside. These are all little things that add up to improved efficiency. So we just touch it, and we'll just start doing a few thousandths and see where that goes. And I shouldn't have a burr. Now we'll look at this and see where our line sits. What I will do sometimes, if I suspect there's burr, is I'll take a little bit of just a silicon carbide sandpaper and just touch that edge to make sure there's no burr on it. And yes, it's not smart to do this crap with a moving machine, but I'm gotta make a living. I cannot stop the machine to do every little process, so get these exactly in sync. I guess we can still go like 3 thousandths. One, two, three. Perfect. Dead center on the line. And now what we want here is 650 thousandths deep, which it is absolutely dead on to the thousandth of an inch. So you see, when the part is cut internally properly to meet up with the center of this line when it slides in, and our depth is exactly 650 thousandths, we're good. That is a good part. Hopefully any of this makes sense. Now, the final thing that I do with it for this part of the process is, once again, another thing that I shouldn't do that's unsafe, so don't do this at home, is I'll use that to scratch a little line in it, because it's way easier to do that to get my length. Lock in the carriage, and once again we're going to run it with that screw gun. We're just going to plunge into it and start cutting. And this is kind of a smoky part of the process, so I'm going to put that there. And you want to run it hard enough to where the chips break. That way they're not stringy. And sometimes I'll take a little bit off on the way back too. Now, we have to get our final dimension here. Back to the dial calipers. And it looks like we have to take off exactly 40 thousandths, which would be 20 on this. We'll do that in probably two passes. Well, we'll do, let's see, 15, and then we'll take 5 off for a finish cut. Now it should be 10 thousandths oversized, and we will verify that just to make sure. Measure twice, cut once, kind of thing. Yeah, it looks like another probably 11 thousandths, so we will go 5.5. We'll go to 6, and that should get me exactly there. Because you got to remember, cuts take pressure. Things have flex and movement to them. Nice amount of oil for this last one. Now we'll check the final measurement on it to make sure I don't have to cut again, because you don't want to go back over it after you take that finish cut. It'll just make it ugly. Exactly dead on. So now what I do is I will cut this shoulder on the way out like that, nice and quickly. We'll get the carriage out of the way. And I use a piece of that silicon carbide sandpaper with a little bit of oil on it. That way I don't get the silicon carbide dust all over in the ways of the machine. And we will just kind of finish it a little bit. This takes off a negligible amount of material. And this is a very worn out piece of sandpaper. But we just want it to look pretty good. It's gonna get finished anyway. I just like them to kind of get a rough finish at this part of the process. We'll ram that towel in there and get all the crap out of it. And there we have it. Hopefully you can see inside of there. And that's a socket. So, when you buy tools, socket tang chisels, from Kimmons Toolworks, that is where your sockets come from. Me on this machine really early in the morning out here, fueled by caffeine and getting it done. So not a lot of, no mass production, just me cranking through stuff here. I know this video took an hour to make. Normally these parts to get to this point take me about a half hour a piece, maybe sometimes longer. It just depends on how well I'm cruising through it, but usually about a half hour a piece. and it's not one of the most time-consuming parts of the process. But these also aren't done. From this point, they'll have to be cut off of here, put into a holding fixture, come back to this lathe, and then be surfaced and have, that's where we get this dimension from. We surface it until we get this dimension right. And then from there, it goes back into that holding fixture, over to the mill, and then that slot is cut centered. And then the holding fixture and the part come back over here, back into the lathe, and that's when they're actually finished. They'll get kind of a decent surface finish on them. Then they get oiled and wrapped in paper, essentially. All of them just get bundled up, and then they go over there until they end up on your chisels. And when they go on your chisels, I usually will take them out again and do another finish on them, just to make sure that they have a good finish and there was no scratches. So that is most of the process for making a socket, and I hope this was enlightening, or that somebody learned anything, or this maybe gave you some insight into, you know, how things go around here, and how much work and how much little intricacy it really is to make these things, because I don't think people realize just how much goes into it, and how every little thing kind of matters and all adds up. So anyway, hope everybody learned something or enjoyed this. Kind of wish it wasn't an hour, but it is. Anyway, have a great day out there, and I will see you next time.